1, we're going to be looking at types of variation. This will go along with worksheet number 1, and then it's also good for the information as far as what you'll need for worksheet number 2. We're going to talk about the 4 different types of variation, and then we will work a couple of examples, and then you will have 2 days to do these problems in class. Okay, so the 4 types will have direct, inverse, joint, and combined variation. So let's go ahead and look at direct variation and then inverse. So direct variation, y varies directly as x if for a constant k, y equals k times x, or y over x equals k. By the way, don't feel like you need to write down everything that's on this screen if you don't have the worksheet yet. There will be a worksheet posted on the website, but you're also going to get a copy of this in class. But you'll just want to write down the examples from each little section. Okay, so y varies directly as x if for a constant k, y equals k times x. In each of these, we will have a variation, a constant of variation called k, and it always goes right next to the equal sign. So in general, if we are given 2 ordered pairs x1 and y1 and x2 and y2 of the same direct variation, then the constant variation k is the same for each equation. Direct variation is a lot like positive correlation or a positive slope. As one goes up, the other goes up kind of thing. So in one sense, k is kind of like a slope if you wanted to think about it that way, a positive slope. So if we have y1 equals k times x1 and y2 equals k times x2, in other words, we're given an input and an output for 2 different situations that are directly related. Then if we wanted to solve for k, y1 divided by x1 would give us k, and y2 divided by x2 would equal k. And since we know that k is equal in each scenario, then I could set each of these things equal to each other. So these are really all doing the same thing. You can use any one of these for solving. So let's look at this example. Y varies directly as x, and then we'll have these 2 examples, A and B. Example A, if y equals 5 when x equals 7.5, find x when y equals 9. So it gives us a complete scenario. We have a y of 5 and an x of 7.5, and then we are looking for x when y equals 9. So if you wanted to go about the long way of doing this, we don't know what k is equal to, and sometimes you'll need to find out what the variation, the constant of variation k is for each scenario. So I'm going to show you between example A and example B how to find example, or the letter k. Alright, so y equals 5 when x equals 7.5. And we know that y varies directly as x. So if y is 5, so we'll have 5 equals, we don't know what k is, but we know that x is 7.5 and x varies, and y varies directly as x. So I have 7.5 right here. So then if we divide both sides by that 7.5, we'll get that k equals 5 divided by 7.5 is 2/3. Okay, so then we want to find x when y equals 9. So now that we know y is equal to 2/3 times x, so if y is 9, we're looking for x, so we have 2/3 of x. So then if we multiply both sides by the reciprocal here, 3/2, that'll cancel out this times 3/2. So then 9 times 3 divided by 2, we'll get 27 over 2, or 13.5. So when y equals 9, x is 13.5. So part B here, if y equals 5 when x equals 7.5, find the equation of variation. So we've done all of that work here in this previous part. So what it's asking for is, we know that y varies directly as x, but to find the equation of variation, we cannot have that k anymore. We need to plug in that k value that we found, which was 2/3. We'll have 2/3 x. So the variation equation, you will have solved for the value for k, but then you'll have your other variables still sitting there not filled in. All right, so there's our variation equation. Now you may be thinking, well, why didn't we just use this thing up here when solving an A? Well, you are more than welcome to. I'm just doing a process that involves setting it up and solving for K each time, because once you know the pattern here, it would be the same thing for any given problem. However, you may have to memorize it for each individual scenario. So if you want to use this thing up here, you're more than welcome to, but know that you would have to have that memorized. All right, let's check out inverse variation. Okay, inverse variation. Y varies inversely as x if for a constant k, y equals k over x, or if you wanted to solve for k, that'd be y times x equals k. So in general, given two ordered pairs, x1, y1, and x2, y2, same thing as before. If we have inverse variation with the same constant of variation k, then we could do the same thing we kind of did before, that if k is equal, then I could set the x times y equal to each other. But this time, instead of it being direct variation where the x was next to the k to begin with, this time the x is underneath the k. So if it's direct variation, x is next to the k. If it's inverse, the x is under the k. So let's look at this example. Y varies inversely as x, and then we'll have if y equals 3 when x equals 10.5, find x when y equals 9. So I'm going to do the same thing that I did before. I'm not given the value for k, the constant of variation, so I'm going to solve for it. So I know that if y equals 3, and then the k always goes right after the equal sign, and then this time the x is the inverse, so we've got over 10.5, or it varies inversely. So if I want to solve for k, I'd multiply each side by 10.5. So now we know that k equals 31.5. But we also need to find x when y equals 9. So if we're looking for when y equals 9 and k is 31.5, to solve for x, we just need to, whoops, don't forget that x is underneath. So to solve for x, if I multiply both sides by x, I'll get 9x equals 31.5, and then divide both sides by 9, I'll get x equals 3.5. So there's our answer for that part. Now we want to write the equation of variation. So again, that just means to fill in that value for k. So we'll have y equals 31.5 over x. So not bad. So direct and inverse, the process for solving is the same. Direct, the x is just next to the k, and inverse, the x is underneath the k. Now let's look at joint and combined variation. Okay, y varies jointly as x and z if for a constant k, y equals k times x times z. So jointly is a lot like direct variation. In fact, it's just like it, except for instead of just having the two variables x and y, now we have x, y, and z. So y is still in the same place, the k is still in the same place, but jointly is just directly with a couple other another variable here. So we'll have x and z are all going to be next to the k. So at this point what we know is that if we have y equals k, directly and jointly would mean the variable goes next to the k, inverse would be underneath the k. And then you could read the same information here saying that if we have two different scenarios, if we solved for k, I could set them equal to each other to solve as well. So let's look at this example. So y varies jointly as x and z. So if y equals 5 when x equals 3 and z equals 1.2, find x when y equals 4 and z equals 6. So we're still going to do the exact same thing we did before, we just have an extra number to look at. Okay, so here we go. So I'm given y is 5. So I always put 5 equals, and then the k goes right next to that. X is 3, and z is 1.2. So to solve for k, 3 times 1.2 is 3.6. So if I divide that on both sides, I'll get that k is equal to 1.389. So there's my constant of variation. So find x when y equals 4 and z equals 6. So if y is 4, now we know k is that 1.389. We're looking for x, and z is 6. So to solve for x, we need to divide by whatever 6 times 1.389 is. And that turns out to be 8.334. So that cancels out, and we'll divide that on both sides. So then we'll find out that x equals 0.480. Part B, if y equals 5 when x equals 3 and z equals 1.2, again, just the same information. So that means we have the same constant of variation. So to find the equation of variation, we just plug that k back in and just leave the x, y, and the z. So we'll have y equals, our k is 1.389 times x times z. So there's our equation of variation. All right, and one more type of variation, and we have combined variation. Combined variation is just what it sounds like. We are using a scenario that is a combination of the other three forms of variation. Okay, so now we have A varies jointly as B in the square of C, and it's not always going to be that. You need to read the words to figure out what it's saying. But jointly as B in the square of C just means the B and the C squared go next to the K. Remember, jointly goes next to the K. And inversely is D, so that means D goes underneath the K. So this is just saying you're going to have to set up the equation with multiple variables and just figure out where each one goes based upon the order of the words. So always just read the order of the words and you're going to get the equation right. So let's look at this example. A varies jointly as B in the square of C and inversely as D. So if we were to set that up, we'll have A equals, and then the K always goes right after that. Jointly is B in the square of C, so we'll have B and C squared. And then inversely is D, so that means the D will go on the bottom. All right, so if A is 3, when, again, we're going to be looking for that K value, B is 0.5, C is 2, but then we're going to square that, and D is 6. So to solve for K here, this 0.5 times 2 squared, so 2 squared is 4, and 4 times 0.5 is 2, so we've got 2 over 6, which is 1/3, right? So we multiply both sides by 3 over 1. And again, all I've done is simplify these numbers into a fraction. Now I'm multiplying by its reciprocal, so that way I can cancel out all of these numbers here. And so 3 times 3 over 1 will give us a K value of 9. So then find D when A is 8, B is 10, and C is 3. So A was our first variable, so it will be 8 equals, K is now 9, as we found out. We are looking for D. So B is 10. And then next up we had C squared. So C is 3, 3 squared is 9. And then all over D, which is what we're looking for. So then if we were to multiply that D over and then divide by 8, then we would get that D is equal to, so 9 times 10 times 9 divided by 8. You'll end up with 101.25. So knowing all of this information to write the equation of variation, we will have A equals, our K is 9, we'll have B C squared over D. So we just fill in that K value for this plane equation we started with at the beginning. Okay. Let's look at one of the problems that you'll have on the back of this worksheet. We're going to actually look at number 4, so you can ignore number 9 there for just a moment. But again, let's just go ahead and simplify what we just saw. So if we have this seems a little bit funny, but right here, this will always be the first variable you're given. In other words, it's your dependent variable. And it will always say something varies as whatever. So this will be our first variable you're given. So that will be right there. K always goes right after the equal sign. And then remember, anything that says directly or jointly, those variables will go on the top, and anything that says inversely, those variables go on the bottom. So you see, you don't really have to memorize all 4 setups from the previous page. If you just remember that this is always your first variable right here, and then you have equals k, direct and joint on the top and inverse on the bottom, then you've got all 4 memorized and you don't have to worry about it. Okay, so let's look at number 4. So the load LD, so that's just all one variable there, that a beam of constant depth can support varies directly as the width W in inches of the beam and inversely as the length L in feet of the beam. A beam of length 6 feet and a width of 1.5 inches can support a load of 5 tons. How great of a load can be supported by a beam of the same material that is 4 feet long and 2 inches wide? Okay, so it gave it to us in separate or different units, and we're just going to be okay with that and ignore the fact that it's like that because our equation should set up and still give us the same information. Okay, so our first variable that was given was LD, so the load that the beam supports. So then we always put our first variable equals K. It varies directly as the width, so that means W will go next to the K, and inversely as the length L. Okay, so then it gives us some information. A beam of length 6 feet and width 1.5 can support a load of 5 tons. So it gives us a complete scenario there, so that way we can solve for K. So if we have 5 equals, we're looking for K, that width is 1.5 and the length is 6. So if I multiply both sides by 6, I'll get 30 equals K times 1.5. So if I divide both sides by 1.5, I get K equals 20. But that's not the final answer. I still need to solve. So if I'm looking for how great of a load can be supported by a beam of the same material, so I'll have equals 20, because that's our constant variation, that has a width of 2 inches, and the length is 4 feet. So that load would be 10 tons. So again, because it told us that how it would directly in which units it was going to be in, I did not have to worry about converting the units, so you wouldn't have to either. All right, so that would be probably the worst or most difficult example on the worksheet number 1, and then you will also have extra problems on worksheet number 2. Let me know if you have any questions, and I will see you in class. Bye!